Okay, so the complex number system consists of the imaginary unit. The imaginary unit I is defined as I equals the square root of -1. So if we were to square I squared would be -1. If I square a square root, we know that the result is whatever was underneath the square root symbol. So I squared would be -1. Now this is different than anything we've ever seen before in math. All right. The complex number system is a completely different system than the real number system. But in order for us to continue along with the same rules and concepts that we normally use in the real number system, we have to have some type of system that deals with the square root of negatives. If we don't have a system that deals with the square root of negatives, then we're stuck. So that's where this came from. All right, a complex number is written in standard form as a plus bi, where a and b are real numbers. So in this case, a is a constant and b is a coefficient, if you will, of the I. All right, a is the real part of the complex number, and the part bi is the imaginary part. So a complex number is called complex because it's got more than one type of number system that we're dealing with. We got a real number, we've got a imaginary number. All right, let's go to the next slide. Okay, here we have some examples dealing with I raised to different powers. Now, at the top of the page, we have our basic values for I raised all the way up to the 4th degree. So you got I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. Everything comes from these 4 situations. All other situations are going to match one of these 4 things. So I'll let you get that copied down, and then we will come back to it. Now, you can see by definition, I is equal to the square root of -1. So anytime we have a square root of a negative number, part of the result at least is going to have an I. You're going to have to pull that -1 out. The square root, let's say you had the square root of -7. All right? Well, you can't take the square root of 7, but you can take the square root of -1. So -1 times 7 is -7, right? So the square root of -1 will be I. So you would have I on the root of 7 if you had the square root of -7. Well, so that's just basic stuff. Now, when we square I, we're squaring the square root of -1, which gives you -1. When you then raise I squared to the 3rd, it's like saying -1 times I, which is -I. And then raise I to the 4th, it's like saying -1I times I again. What happens? I times I is I squared, which is -1. -1 times -1 is 1. So these are the 4 possible situations that you have when you raise I to an exponent. So no matter what the exponent is past 4, it's going to end up being one of these. Okay, there's only 4 possibilities. So if I had I to the 3001st, it's going to be one of these things. No matter what it is. If it was I to the 1,257,363, the result is going to be one of these 4 things. These are the only 4 possibilities. Because after this, everything starts to repeat. So if I go to I to the 5th, it goes back to this. If I go I to the 6th, it's this. I to the 7th, this. I to the 8th, we're back to this. And then it just starts over again. Okay? So every 4, whatever, as your exponent increases by 4, you're just starting over. So we're basically looking for multiples of 4 for the exponents. Now, I to the 5th. So we're just going to go down the line here. We just said if we start over with I to the 5th, we're back to where we started. Okay? So I to the 5th is just simply square root of -1. Okay? I to the 6th, -1. I to the 7th, -1I, or you can just say -I, however you want to do it. You be careful with your eyes now. Make sure you put the little dot. I think it's good to make a little cursive I, because that way it doesn't look like a 1 at all. All right. I to the 8 is 1. Okay, so again, these are your 4 situations that you're going to have. Now, look at I to the 47. I to the 47 is different than what we have, right? Hey.
Hey, Coach Schneider,
Hey.
I'm sorry about it. Can I borrow you for like 1
Yeah,
minute?
let me stop this real quick. All right, so I to the 47. So anytime you're dealing with an exponent greater than 4, what we want to do is simply divide that exponent by 4 and find the remainder. It's that easy. So what's 47 divided by 4?
It'll be negative, or it'll be the root of -1.
Well, yes, but let's find the multiple of 4 that's closest to 47. What is it? The one directly under 47. 11. Okay? So 44 divided by 4 is 11, right? So 44 is the one directly under that. Well, 44 plus what is 47? 3. Go to I cubed. The answer is -1i.
How you got that?
Alright, so let me show you. I'm going to show you. Let me change color. Alright, so all I did was I did 47 divided by 4. You can do it in your head or you can do it somewhere else. I mean, I don't really care where you do it, but this is just how you do it. 47 divided by 4. Oops. I'm running out of room here. But you can see. The remainder is 3. Okay? Whatever the remainder is, you go to your original list. That tells you what the answer is.
So the highest multiple, then you subtract everything, and that's what it is.
Yes, you can't be more. Your exponent, your remainder's never going to be more than 4. Okay? If it's a remainder 0, what does that go with? If it's divisible by 4, you know what I'm saying? If it's remainder 0, if there is no remainder, that means it's divisible by 4, and it's just 1. Huh? You always divide whatever the exponent is by 4. Because why? Because there are 4 things. Alright, so let's do the next one. I to the 60. So 60 divided by 4 is 15, right? So, is there a remainder? No, there's no remainder. Remainder equals 0. So, you always go to the 1, to the 4th one when there is no remainder. So, it's 1. Okay? Alright, let's go to 126 divided by 4. Alright, so 4 goes into 12. 3 times 12. Bring down your 6. 4 goes into 6 one time. 4. Remainder 2. Remainder equals 2. So, -1.
Yeah, I know how to do it.
Okay?
I'll do it right here.
Alright, y'all do the next 3 on your own. And then I'm going to call on you. Okay, so in this next one, you got I to the 73rd, so I'm going to put it on top so I have more room. 73 divided by 4 goes, we're going to just divide it, okay?
18.2.
So my remainder is 1. Alright, my remainder is 1. Square root of -1, sorry, is my result. Now, if you just put I right there, that's fine. Okay? What is my remainder? Huh? The answer is square root of -1 or I.
So why did you say
The remainder is 1.
Oh.
73 divided by 4. You take whatever the exponent is and you divide it by 4. Why? Why 4? We got 4 things up here. Okay? Alright, so the next one, 52. Alright, 52 divided by 4.
1.
52 is divisible by 4, right?
Yes.
13 times 4 is 52. I'll show you. Alright, the remainder is 0. Anytime my remainder is 0, the answer is 1. Always. Okay? And the last one. What do you do?
Okay. 5 4 is 198.
Mm-hmm.
Okay. 4 times 4 is 16.
Okay?
And you have 3 left.
got 38
Okay.
left.
38. And then 4 times 9 is 36.
Okay?
And you got a remainder of 2, so it's equal 1.
Outstanding. There you go. Okay. Very good. All right, let's.
My boy know how to do it.
Okay, are there any? Okay, let's go over these answers real quick. All right, so we divide 109 by 4. What's the remainder? The remainder is 1. The remainder is 1, so the result is square root of negative 1. Now, here's the thing. For this particular part, you know, I is equal to the square root of 1. If you just say I, that's okay too for that one. All right, 57. What's the remainder? Remainder of 1, so square root of negative 1. Okay, 68. What's the remainder? 0. So the answer is 1. All right, 75. The remainder is what? 3. So the answer is negative I. Negative 1I or negative I, they mean the same thing. All right. 222. Remainder 2. So that's going to be
Negative 1.
negative 1. Not negative I, negative 1. All right. Be careful. Make sure you know the difference between I and a 1. All right. 51.
3.
Remainder's 3, so the answer is
Negative I.
negative I. Okay, 188. The remainder what? 0. So 1. 311 is remainder what? 3. So
Negative I.
negative I. I think the more you do of these, the more you'll remember what the different exponents are. You know?
Wait,
I can remember the full thing about it.
I got it.
I'm being smart.
Here we have the addition, subtraction, combination of like terms, however you want to think of it. What we want to do is we want to find the real numbers x and y to make these equations true. In other words, if I've got 8 minus 12i on the right side, this left side's got to be 8 minus 12i also. Over here, if the right side is 20 minus 3i, the left side has got to be, all right, so negative 20. Negative 20 minus 30i. The left side's got to be the same thing. Well, it's not that complicated, okay? We can easily determine what x and y are by just doing a little bit of mental math, all right? You're not going to have a ton of these types of problems, but it's pretty simple. I'm going to let you think about it for about a minute, and then you should probably be able to fill in the blanks, basically.
That's separate problem.
These are 2 separate problems, yes. I want you to be able to do a problem like this mentally, because you got to understand in this problem, these problems, there are 2 parts to every complex number. You got your real part, you got your imaginary part. So in this problem, we've got a real part. How do I know this is the real part?
Because it's got a coefficient of 4.
Because it does not have an I. Okay? So this has got to be the imaginary part. Over here in this problem, real part, imaginary part. Okay? Now, the real part goes with the real part, right?
Yeah.
So if I wanted to put up an equation, I could do 4x equals 8, x equals 2. Now, do I really need to do that?
No.
I mean, I can see that there's an 8 here and there's a 4x here. This has got to be 2. These aren't complicated, right? All right, now look at this one. So the next one would be negative 4yi equals negative 12i. Now, if I've got i's on both sides, what happens? They cancel. So now I can just find my y, and my y will be equal to 3.
So it's like a regular equation. You just, and the i's cancel out.
Yes, you just match up the parts. Okay? Now, did I need to go through all that? Now, normally I require you to show your work, right?
Yeah.
On this, guys, some things you need to be able to do in your head.
So basically,
Alright.
you basically just.
Well, you're going to see my work. I'm not.
You can do it. You can always show your work. Don't get me wrong. But now,
That was my problem with Portia last year. Like, she always wanted everything else to do. most of everything she wants to do in her head, like when she's going over stuff, like working on the board.
Okay, so you should see that it's going to be -4, right? But 5x equals -20, x equals -4.
And Y is negative.
And 6yi equals -30i.
I either, yeah.
Cancel.
Oh, yeah. White.
There you go. Okay? So those are pretty simple. Alright, so here's some more.
Yeah.
Let's do these.
You taking this test tomorrow? You need.
No, we're not taking tests tomorrow.
That's
I don't
what
think.
add.